We're working on this 2011 Buick Lucerne. We're going to be looking at the ignition system today. So we pulled out a spark plug. So the plug out of this car is an AC Delco Iridium plug. It calls for a 40 thousandths gap, and that's just exactly what we have here. We're also going to go ahead and test the resistance. Right now we're just set to continuity, and we can see that there's no continuity through this plug, meaning there's a gap instead of a resistor. We're now looking at the system overview. This is an electronic ignition system where the ignition module receives input signals from the PCM, primarily crank and cam position sensor signals, and interprets these and transmits a secondary voltage while regulating the sequence, dwell, and timing of this spark. Here we have the ignition control module and coil assembly. You can see it's located on the back side of the engine above the valve cover. It's not possible to test the primary coil resistance through the module, but the secondary coil resistance can easily be done. Placing your meter leads on the coil towers as shown in the picture with the arrows, you are looking for 7 to 15,000 ohms. The secondary coil resistance results, they are all right about 10,000 ohms. This is the ignition control module connector and pinout. We have our first channel of the Pico onto our ignition control 1 circuit, the purple wire and the connector going to the module. And we have our voltage paddle reading our 1 and 4 coil, which is the triggered off of that ignition 1 control circuit. Alright, so this channel A, we have a 5-volt signal for the ignition coil 1 from the PCM into the ignition module, and signal B is our voltage from our coil 1-4. And so here we see the dwell time, we see the fire and the fire line, and then going back down. Looking at the ignition coil operation description, we are able to break down the picoscope readings even further. First, in the yellow, we have the ignition control circuit on. That is our 5-volt signal on the purple wire telling coil 1 to fire. See in the yellow, that is the 5 volts turning on. Next, we have the current flow through the primary coil windings in the green. And that is our dwell time. That's the saturation of the primary coil. Next is the ignition control circuit turns off. That is the blue. And immediately after that, the pink happens. That is the collapse across the magnetic field, causing the voltage spike. And that will internally cause the orange, which is the firing line, and that is the high voltage crossing the spark plug gap until it can no longer provide enough voltage to cross the vat. We have the ignition control module schematic, where I've highlighted the first bug we are going to introduce.
Before testing, these are the codes that the car currently has.
We are probed into the purple wire going to the ignition control 1, the IGT circuit, to the coil 1-4, and we're going to be grounding it to see how the motor acts while it's running.
When we ground the coil, you are going to see cylinder 1 and 4 start to misfire. These top 2 codes were present before the test, but we have a new code here on the bottom, P0351, which is a very specific code. You can see we caused it. It is ignition coil 1 and 4 control circuit code.
The schematic for our next bug, taking note of the 15 amp fuse that feeds the circuit. We are now on the pink and black wire in pin F of the ignition module connector. This is the ignition voltage to the whole module, and we're going to see how it acts when we ground it. We're now grounding the ignition voltage to the ignition module.
After the car died, it would not start upon cranking.
Alright, this led us to mini fuse number 3, fuel injector even 15 amp fuse. Taking a look here, it is blown. Bug did not set a DTC, although it prohibited the car from starting. This concludes our ignition system investigations on this 2011 Buick Lucerne.